y mean. Predict y minus average square summation. This is explain the variation. Total variation is y minus y mean square. And unexplained variation. Unexplained variation is a summation of y minus y hat square over degree of freedom. And this is standard error of estimate. This is definition from definition. And after you plug y hat in, and y hat is b0 plus b1 x b1 b1x, plug it in and then square it. Finally you can get this formula, so equal this formula. What is the standard error of estimate? Is the standard deviation of the observed y values about the predict y hat values. So y minus y hat is unexplained variation. The standard error of estimate measures how the values deviate from the regression line. How the values deviate from y hat is the regression line. So the question 13. Consider the data in questions 3, 4, and 7, which is student absence and the final grade question. Compute the standard error of estimate. Since the standard error estimate, we will use this formula, and this formula we need summation of y squared. So from question 4, you can figure out summation y squared is 38993. Summation y, we need summation y. From question 4, you can get 511. And we need summation of xy. And you can find 3745. And b0 is from question 7. Is y-intercept 102.493. b1 is the slope negative 3.622 is a linear regression line, and plug it into this formula. Summation y squared 38993 minus b0 102.493 times summation y 511 minus b1 is a negative 3622 times summation of xy is 3745 over degree of freedom n minus 2, 7 minus 2. And then use calculator, you can figure out and round it to 3 decimal digits, you got 6.058. Then this means, hence the standard deviation of observed values about the predict values is 6.058. And question 14. Consider the following data. If x is 28, 20, 29, 30, 31, 32, 33, and the y value, corresponding y value is those, and given this data, and want to prove the regression equation, linear regression equation, or least square regression line, also called linear regression line, also called least square regression line, is y hat, and we need to figure out b0, b1 from the data. And that's will show b0 is 21.466, show b1 is slope is 3.438, and b, compute the standard error of estimate. So we will use b0, b1 formula. b1 is slope. So we need n here is 1, 2, 3, 4, 5, 6. N equal 6. N use 6, plug it in. We need summation of xy. So you will do x times y. The two number times together, then you add together, which get is 23177.64. You need to make a table. In the table, you you list out x on one column, y on one column, and find out summation x is once add x together is 183. Add y together is 757.95. Then you do x 28 squared, add 29 squared, add 30 squared, add 31 squared, add 32 squared, add 33 squared. Use calculate, you got 5599. Then y squared, 117.11 squared, add 123.26 squared, and etc. Add 136.1 squared, add those two square, and you got summation y squared is this, 95963.6439. So because we need those to figure out B1, B0. In B1, n equal 6 plug in summation xy 23177.64 plug in minus summation of x 183 times summation of y 757.95 over n is 6 times summation of x squared. X squared is 5599 minus summation of x is 183 squared, and figure out, use calculate, figure out is 3.438. It's positive. This is slope, it's positive. B0 is a y-intercept, and use formula, summation of y, plug in 757.95 times summation of x squared, 5599 minus summation x 183 times summation of xy is 23177.64 plug in over n is the same. N is 6. Summation of x squared is 5599 minus summation of the two denominator is the same denominator. And use calculate, figure out is 21.466. That's proved. Show that the regression equation y hat, y-intercept B0 is 21.466 plus the slope is 3.438x. That's proof, show. So you have to show B0, B1. Then B, compute the standard error of estimate. S estimate is equal square root of, use this formula, summation of y squared minus b0 summation y minus b1 times summation xy over degree of freedom n minus 2. N is 6 minus 2. Summation of y squared is 95963.6444. Plug it in. Minus b0. B0 is 21.466 times summation of y. Summation of y is here 757.95 minus b1. B1 is 3.438 times summation of xy. Xy is 23177.64. And use calculator, figure out, is get 1.480. Then your hence answer the standard deviation of observed value about the predict value is 1.480. Question 15. A college statistics professor is interested in the relationship among various aspects of students' academic behavior and their final grade in the class. She found a significant relationship between the number of hours spent studying statistics per week, which is x1, and the number of classes attended per semester, which is x2 variable, and the number of assignments turned in during the semester, which is x3, and the student's final grade is y hat. And this relationship is described by the multiple. This is a multiple regression equation because we have x1, x2, x3, 3 variables. And this kind we call multiple regression equation. This equation we call multiple, not only 1x. There's a 3x, 3 variable x. and the independent variable x1, x2, x3, and get the linear equation y hat is equal negative 14.9 plus 0.93359 x1 plus 0.99847 times x2 plus 5.3488 times x3. This is multiple regression equation. x1 represent the how many per week, how many hours studying statistics. x2 variable represent per semester attend the class how many times, x2. And x3 is how many assignments turned in, is x3 variables. Predict the final grade for a student who study statistics 8 hours per week, which is x1 is how many hours study. So x1 use 8 plug in and attend 34 classes. x2 is how many classes attend. So it's 34 plug into x2 Then turn in 11 assignments. So 11 is x3. x3 is how many assignments turn in. So 11 put into x3. So in this linear regression line, x1 use 8 plug in, x2 use 34 plug in, x3 use 11 plug in, and use calculate, figure out, you got y hat equal 85 point rounded. This is 5, so you round up, it's 0.75, and that's the student's final grade. Question 16. An analysis results in a multiple regression equation y hat equal 56 plus 22x1 plus 4x2. This is multiple regression because it has 2 independent variables. We can conclude that the variable x1, the variable x1 is a very significant factor in this model. Can we conclude that? B, the variable x1 is a moderated, a significant factor in this model. C, the variable x1 is a not significant factor in this model. D, this is insufficient information to assess the significance of x1. Answer is D, because the value for x1 may be small compared to the value of x2. So is a significant, the value of x1 may be larger than x2, or maybe smaller compared to x2, maybe smaller or larger. We don't know. So which one is significant? Probably x1, probably x2. So this is insufficient information to access the significance of x1. The next question, in multiple regression model, y hat equal negative 10 plus 4x1 plus 21x2 plus 16x3 plus 2x4. If the x1 value change by 2, then the predict value y hat will change by what? So you change by 2, so like x1 increase by 2, then 2 times 4, and you got added by 8. So y hat increase by 8. So answer is 8, because if x1 increase by 2, then 2 times 4, you got 8. So the y hat is increased by 8, changed by 8. So answer is A.